1, 2, 3.
Can you hear me?
Oh, I can hear your beautiful dulcet tones.
Oh, yes. Dulcet. That's exactly the word that I'm usually looking for.
This episode is sponsored by Hired.com. Are you searching for a new job? That can be stressful, scary, and time-consuming. Pushy recruiters try to sell you on roles you don't actually want, and the job boards make you feel like you're throwing your resume into a black hole, never to be seen again. And sometimes you go all the way through the interview process just to find out at the very end that the salary, offer, or company culture doesn't match what you're looking for. Hired is the world's most intelligent talent matching platform for full-time and contract opportunities in engineering, development, design, product management, data science, sales, and marketing. We make your job search faster, focused, and stress-free. Instead of endlessly applying to companies and hoping for the best, Hired puts you in control of when and how you connect with compelling new opportunities. After completing one simple application, top employers apply to hire you, and on Hired you receive personal interview requests and upfront salary information so you can make informed decisions about what opportunities to pursue over a condensed timeline. Hired offers access to more than 4,000 innovative employers, including big brand names like Facebook and smaller emerging startups. The size and type of company you want to connect with is totally up to you. And we help you find new opportunities in 17 major cities in North America, Europe, Asia, and Australia. Open to relocation? Let them know. Your privacy and autonomy in your job search is of utmost importance. And if you sign up today using the show's link, that's hired.com/rubyrogues, you can get double the normal hiring bonus. That's $600 instead of $300. So go check them out at hired.com/rubyrogues.
Hey everybody, and welcome to another episode of the Ruby Rogues podcast. This week on our panel, I guess it's just me, and we have a special guest this week, and that's Dave Thomas.
Hey there. You see what happens? I come on the show and everybody else aborts and leaves. So, that's just the way it goes, I guess.
Yeah, I know a couple people had some teaching engagements. Yeah, now that I think about it, I think pretty much everybody had something going on. So
yeah, like a trip to the dry cleaners or something like that.
Yeah, I think Dave said he had a launch. I know that Jason's doing a workshop. I think Jerome was doing something for Vets Who Code. I'm not sure where Brian is. So anyway,
Vets Who Code. That's a cool thing.
Yeah, it is very cool. Anyway, we were talking yesterday actually for my Ruby story. I think this episode will come out before that one will. But you mentioned that you are teaching part-time at Southern Methodist University, and you're teaching an advanced computer science course. And I think you tongue-in-cheek mentioned that you were teaching advanced concepts like testing and source control.
The tongue was nowhere near the cheek at that point, unfortunately. But I have been meaning to get into higher education just to have a look to see what's going on, because I have some ideas on things that are wrong and things that are right, and it always struck me that going around espousing those without actually having any direct experience of it was kind of a bit cynical. So when I pulled back from working full time at the bookshelf, I approached SMU here in Dallas and said, hey, is there a class I could teach? And I was kind of surprised at how easy it was to get in there. It was, I think they were quite keen to get some outside influences. So it actually worked out well for both of us. So I turned up and I had like a discussion with them. And they have, obviously being a university, they have a curriculum that they have to follow. And so there's kind of like a set list of courses, and they were like, well, do you want to teach this one? And I said, no. And then they finally got to one called Advanced Application Development. And I said, oh, what's that? And they said, pretty much whatever you want it to be.
Nice.
So I said, sold. All right, I will do that. And so that was maybe March or something like that. I signed up, and the course started end of August. So I thought, hey, no problem, plenty of time. Well, that's just like, typical software timekeeping. It turned out it was pretty much a full-time job between March and August to actually get a course in place. I had no idea. But turned up on the first day, and from just basically I taught twice a week, had a total blast. It was a really good time. So, but talking about like basic skills, it's kind of interesting because the class was, what are they now? I guess they're seniors and master's students in the computer science department. and they were all bright people. They're all, really enthusiastic people. But their courses so far had concentrated very much on, I guess, the theory side of things.
Mm-hmm.
So if you ask them some graph theoretic question, they'd knock you dead with it. But they really hadn't done any of the basics, I think, of programming in the wild. So they were sort of familiar with version control, but only because they used it on personal projects. Really not familiar at all with testing, and not particularly familiar with even basic design ideas like decoupling and that kind of thing. So my intent was to go in there and subvert them with some Elixir. And it turned out I was subverting them with a whole lot more as well. I made them, for example, all of the assignments were coding assignments, and every single one of them, they had to generate a pull request, which meant we had a full lesson at the beginning on what is a pull request. But once we got over that, it's kind of interesting. You show people tools that actually work for them, and they really, really quickly get enthusiastic about it.
Yeah,
to the point where they worked at. To the point where they worked out how to subvert the pull requests and actually look at other people's submissions and cheat a little bit. So, but apart from that, it worked quite well.
Yeah, it's really interesting. I mean, I went to school. I studied computer engineering, so I took a blend of electrical engineering and computer science classes. And yeah, I took one class where it was sort of, okay, here's basic stuff about working in the programming industry. And I remember we used advanced software like CVS. I mean, then this was only 12 years ago, but still, Subversion was out. Git really wasn't a thing, but anyway, so we learned CVS for the course. We talked a little bit about agile development, but yeah, I mean, for the most part, it was, here's what it's like to work on a team. And yes, all of your grades are dependent on your team. But yeah, it was funny because, I got out into the real world and started writing real software, and there were so many things that we just never even went over. I mean, testing was a completely foreign thing that had never even been talked about in any of my computer science classes. They were much more focused on the theory and algorithms and things like that. I mean, even design patterns I hadn't really been exposed to.
Yeah, I think a lot of the time, the people who choose an academic career tend to get into that. They do their degree, they do their master's, they do their PhD, they go get some position, associate professor or whatever they call it. And then eventually, if they're lucky, get tenure and really never spend any time out in the non-academic world, in industry. And so they really don't know. I mean, it's not necessarily their fault, but they really don't know what's important when it comes down to, nuts and bolts programming. They know a whole bunch about, how to succeed in universities. But given that maybe, I don't know what the percentage is, 1 in 20 or something of their students will actually stay on in academia, they're really not serving, the majority that well. But, it's kind of interesting to see because at the same time, I mean, that is my biggest complaint, and that's my biggest kind of mission, is to kind of chip away at that a bit. At the same time, I think the other thing that is sorely lacking in computer science education, and not just in universities, but in schools and to some extent in the boot camps and everything else, is motivation, because it's being taught as a theoretical discipline of some kind, like chemistry would be, or math would be, or something like that. Mm-hmm. And nobody really gets across the fact that if you really get into this, it's fun. It's not just a job. It's actually a great way of, exploring your world and digging into things and solving puzzles, et cetera, et cetera. It's a great challenge. I read somewhere, somebody said fairly recently, and I wish I could remember who it was, that in a way, programmers now control the world.
Oh,
and I think there's actually, there's some truth to that.
Mm-hmm.
And we do a whole bunch of harm accidentally, but I think we also do a whole lot of good. I think that we, in so many ways now, are helping the world get better and bigger and more complicated and whatever else. And I think if we were to teach that and to show people that, this is a job where you make a difference and do it responsibly, that would be a major step forward.
So I'm curious then. I mean, it sounds like this is you're only teaching the one class, and you probably get each of these students for one semester at a time. So how do you get all of this across? Because it sounds like it's part practical application of skills for programming and part sort of catch the vision of what programming can be for you and can be for the world and can be for your peers and your family. So how do you capture that for people?
I don't think you get it. You don't capture it by telling them, I don't think. Or at least not directly. What I tried to do, and I mean, this is the first time I've done it, so I'm not like, the expert on this by any means. But fundamentally, what I tried to do was to be enthusiastic. Because if you wander into classes, because I have the ability to just kind of like walk around the school and just stick my head in, and because I look like I'm older than 20, the professor just nods at me and I nod back at them and then sit down and look.
Nice.
And it's it's almost like you're going to, a funeral, and the service is being given by some priest who never actually knew the person, So, Java was a good programming language, much loved in the community. Everybody thought highly of Java, and Java gave back in the same kind of way. We'll miss you, Java. And it was that kind of, dire feeling. And I just tried to make it more interactive and more fun in a way, and just not take it seriously. I mean, take the underlying stuff really seriously, but joke with the students and sort of make fun of myself and stuff, and every now and then tell a story. And there are some. I mean, I haven't had a dramatically influential life in terms of programs I've written, but I've written some that have been kind of widely used. And, telling people stories of, the first time you go and, you walk down a street and you look in a shop window and you see a program that you wrote being used, it's kind of yeah, we make a difference, Yeah, you can talk, I was peripherally involved in the satellite that went to Halley's Comet. And, those kind of stories are just yeah, I mean, it's not just sitting there writing an algorithm, but it's actually making stuff in the real world actually change, which I think is important.
That makes a lot of sense. No, and yeah, that's really part of the excitement.
Yeah, it is. It really is. And I think there's another side to that as well, and that is people don't get this concept of software as an agent for change. And there's two sides to that. One is the kind of social side, but the other is the personal side. And if you're a writer, then your tool is words, and if you're a painter, your tool is paint or whatever it might be. And the tool is not the important part. The important part is the fact that you have something inside you that you want to get out. You're driven to express yourself somehow. And so, you try and make a painter not paint, right? They'll find a way, they'll sit there on a tabletop and draw in the condensation of their beer glass just because they're driven to do that. And I think a lot of people in software, I mean, they don't paint, they don't write, but they still need to express themselves. And I think that's another enthusiasm you can get across to people is this is a medium that you can get all of those kind of inner thoughts out. And this is where you can interact with people on the other side of the planet, in a way that you want to interact. So there's a lot to it. There's a lot of different reasons, I think, why software is a really good thing to get into. And we do a really crappy job of explaining that to students, which I think is why it's kind of interesting, because I'm also getting involved locally with some after-school programs for software. And the ones that succeed are the ones that don't really do software head-on, but instead, they're building, one of them is doing a Raspberry Pi web server that then drives a robot, so you can sit there. And these are 10, 12-year-old kids. and they're sitting there, burning stuff onto their Raspberry Pis, and they're having a blast. And it's really impressive. A good teacher will basically do all the whiz-bang stuff. Gee, look over here, the lights are flashing. But at the same time, they'll be explaining, well, this is a variable, and this is a loop. And they even sneak, it's really quite wild. I watched one of these guys, they were putting a web server up on a Raspberry Pi, and he was explaining the difference between HTTP and HTTPS, and then used that as an excuse to get into security. And he's telling these kids all about why they should never enter their details on a site that didn't have a little green box on it and this kind of stuff. So that kind of thing, I think, is really the future of training, I guess, for software people. I think universities have a place, but fundamentally, that's not where you develop developers. That's where you give them facts. I think you develop developers way earlier by showing them that this is actually something they can do, and it makes a difference.
Yeah, that totally makes sense. So I have so many questions. One of the things that kind of came to mind while you were talking is, then if most of the computer science graduates are not going to go into academia, they're probably going to go into our industry and be writing software for some company somewhere. So do you feel like then that a lot of these computer science programs are not preparing these students to go out and do this kind of work? Or is it just that their focus is completely different? Maybe that the outcome isn't well understood?
I cannot speak for all courses.
Right.
I think that the people that come out, okay, so if I'm looking at the people that come out of SMU, for example, they come out as very highly skilled in the, I hesitate to use the word science because there isn't any, but the theoretics of computer science. They can certainly program, and they can write complicated programs, and they understand, algorithms and big O and computer architecture and networks and this kind of stuff. All of which is a really good set of facts to know. I think the assumption is that they will be able to pick up the rest in their first couple of jobs.
Okay.
So I would say that almost every university department, four-year university department, is not preparing people to walk straight into a job. They are instead preparing people to be able to hold their own as they learn what the real world is like.
Is that sufficient? I mean, it's where we're at right now, and it seems to work to some degree, but is there a better way?
Yes, very much so, I think. I think a four-year program is what you do after you've had 2 years worth of experience rather than before. Because 90% of what you're learning in a four-year program makes no sense or is not motivated until you've actually experienced the problems. Like, for example, take something simple like, version control, right? What is the point of version control if you teach it as an abstract set of theories? And I've never sat in on any class that talks about version control. If they were there, my guess is they would be talking about, how Git manages its graph and, all the various hashes and this kind of stuff. And no talk at all about, Fred over there is an idiot. This is how you undo the damage you did. And that's the important stuff. So if you actually had the experience in the field and you went and you used Git for 2 years and you realized that, yes, this is a really useful tool, then it's really useful after that to understand how it works, because then you can make more informed decisions as to, do I rebase or not, and that's where the kind of the theory behind it comes in. So if I was like, if I could wave a magic wand, which I do quite a lot, just doesn't do anything. But if I could wave a magic wand and make a change, it would be that you did some kind of like a sandwich course where you had maybe a year on, a year off, a year on, a year off, alternating between academics and real world programming. So that you could actually, apply both sides. You could actually, learn the theory and then apply it in practice, but also learn the problems and then go back and work out how the theory actually helps fix those problems. So that would be, I think a 4-year course where you actually do 2 years worth of academics and 2 years worth of practical, industrially kind of programming would much better prepare people for what they were going to get into. And I think also would actually help the university, because it would bring back to the university knowledge of what was actually going on the outside, and students asking questions that might be slightly uncomfortable for the established professors to answer. But once they went and researched it, they would actually learn something too.
Yeah, that makes sense. So what exactly do you teach in the class? I mean, what does your course outline look like?
What I try to teach is that within the next couple of years, these people who graduate will not be writing C++ or Java. They'll probably be writing a functional language. And so I try to get them to understand how you write in a functional language. Mm-hmm. And I try to do that at a kind of practical level. So, we are writing a hangman game that ends up having, it starts off as just like a couple of Elixir applications, a dictionary, and a hangman server. And then we will add a text client to that. And then we'll add a Phoenix web server to that serving HTML. And then we'll have another Phoenix web server that serves basically JSON down to a smart client in JavaScript. And the game itself is irrelevant. What I want to show people is that at each step, you don't bolt extra code into something. You keep it all as little separate, I guess the buzzword now is services, that all interact with very clean interfaces. And inside those, all you care about is state and transformations. And about, 15 weeks in, it's not 8 weeks in, 15 courses in, somebody suddenly realizes that what they're actually doing is implementing objects. And mm-hmm. That's kind of like a magic moment, because when that suddenly clicks, then you can say, yes, and all of these good things you've learned about OO design apply equally well here, just better. And so that's what I'm trying to teach. Is more, it's very much a kind of how to think as decoupled services in a functional environment.
Yep, that makes sense. Now, you said something interesting there. You said that in a few years, most of these people are going to be writing in a functional language. Do you feel like that's the direction that programming is going? That
Absolutely. And there's a couple of reasons for that. I think that one of the reasons that Elixir is taking off so rapidly is that it meets a need that's been there for a long time. The world, or the programmers in the world anyway, have been looking for a practical functional language that actually has definite benefits. And so they've had Haskell, but let's face it, practical and Haskell don't necessarily belong in the same sentence. There's been Clojure and Scala. Clojure is relatively pure, but it still has this kind of like weird interaction with the JVM that kind of like, to my mind, you're half doing Clojure programming, and then you're half trying to work out how to interface that into a real world. Elixir is nowhere near as cleanly functional as those other languages, but it's functional enough. And I think you can write excellent code in a functional style in Elixir. And at the same time, you can write some kick-ass web services or whatever else. It's rock solid. It's probably the oldest virtual machine out there. So, it's pretty much bulletproof. And then the language itself is a ground-up implementation that takes advantage of that Erlang virtual machine. So you really get the best of both worlds. So I think partly that's, that, if you like, is an indication, just this sheer hunger that people have got for functional languages. Then on the other side of the coin, there's this, stop me if I've done this little rant before, but I did some research into Moore's law, and in particular, why don't our processors get any faster? And I'm sure you've noticed that, over the last maybe 10 years, we've pretty much topped out at the speed. We're sitting there running between, 2.5 and 3.5 gig maybe on our processors. They haven't got any faster. In fact, in some cases, the next generation of a processor is actually slower than the one that preceded it. But what we do to make up for that is we have multiple cores. And I now see we're getting like 16 core machines are, the next generation. Although weirdly, 18 cores, which I don't quite understand how you get to 18. But anyway, so we have, all these multi-core processors. And it turns out the reason for that is physics, basically. Actually, it's not physics. It's more a rule of thumb. There is a rule of thumb guide that says that the power that's dissipated by a processor is proportional to the cube of its clock speed. So if you double the clock speed, the power consumption goes up by a factor of 8. And power obviously ends up being nothing more than heat, which is why all of the guys that are making their gaming computers, are sitting there, worried to death about overclocking, and they're sticking like water cooling systems, so they can play a faster game of Doom or whatever it is they're playing. And that's just purely heat, right? So you've reached a limit in terms of clock speed. If you try to eke out another 10% increase in clock speed, you're getting to the point where things are melting. So instead of doing that, they're going to have multiple cores running slightly slower. And it turns out that if you do that, your performance per watt actually increases dramatically. So you can actually run, basically you can get a ratio down the bottom ends. You can pretty much double your processing power and actually drop your power consumption just a little bit. And the more cores you put in, the better that looks. So because of that, everybody's going multi-core. Well, that's great in terms of the theory, but now all us programmers have to sit here and we're looking at this machine that has 16 cores on it. And if all we do is write programs that are basically serial, start one place, end up another place, then we're only using 1/16 the power of that machine. And our clients are going to start bitching at us because, wait a minute, I just bought this, $3,000 processor and it's performing worse than my cell phone.
Right.
So how do we fix that? Well, obviously we have to fix that with parallelism. And 90% of the languages out there suck big time when it comes to parallelism. Right? It is very, very hard to write, for example, a concurrent OO program simply because your state is shotgunned over hundreds of thousands of objects spread all over the processors. How on earth can you maintain consistency across all of that? And so we end up with all of these kind of like really weird schemes and, rules of thumb to say, do this in this order and this in this order and all this kind of stuff. But it never quite works. And I would guess that there are probably, with the exception of things like pacemakers and NASA, my guess is there isn't a single concurrent OO program out there that doesn't have some kind of bug in it to do with concurrency.
Right.
Dear Ruby developer, are you sick and tired of working on crappy old legacy code bases? There's got to be a better way. If you want to get a better job, here's what you can do. Find a technology that's really in demand, build a side project using that technology, and then use that side project as experience to get your next better job. I've done this myself several times. It definitely works. What I think is a really good technology to learn right now is Angular. Angular is really in demand right now, and it's not going away anytime soon. I have a free guide to getting started with Angular and Rails at angularonrails.com/rr. Good luck and enjoy this episode of Ruby Rogues.
So another way of fixing that is to change your programming model. If you make all your data immutable, then a whole bunch of your concurrency issues just go away because you're never going to get race conditions into that data.
Mm-hmm.
Instead, what you're going to do is you're going to get two different copies of the data that may have different values. But it turns out that's a lot easier to handle than trying to protect access to one big mutable copy. So for those reasons, I think immutable data is pretty much a given. And then once you've got immutable data, well, OO kind of disappears because it's going to be read-only OO. An object only has one state, its initial state when it's created. And if that's the case, then fundamentally you're doing functional programming anyway. So bite the bullet and use a proper functional language, because that lets you express that functionality far easier and far more accurately. So for those two reasons, I think the future pretty much has to be functional, at least until something better comes along.
Mm-hmm.
So I think what we're seeing right now with the rise of Elixir is, and to some extent the rise of Clojure and Scala as well, is that we're seeing the transition that took place, I don't know, maybe end of 80s or something, when we went from procedural to OO. I think we're now seeing OO to functional. And in the same way that it took maybe, I don't know, 5 years, 10 years to switch, I think we're going to look at maybe half of that, so maybe 3 to 7 years or something like that, to switch across to a functional, where it becomes the norm to write in a functional style.
Gotcha.
So, and I mean, that's just me pontificating, but I've been saying it for, I don't know, a few years now, and I'm happier now that I'm actually beginning to see solid evidence of that. I mean, even like, if you look at job ads, I was chatting with you yesterday about something else, and we were talking about, like, I go to Ruby conferences,
mm-hmm.
and I still love Ruby. Ruby is it's been very good to me, and I've tried to be good to it back. I still code in Ruby quite often. But when I go to a Ruby conference and I chat to people, almost everybody I chat to is experimenting or has switched over to Elixir. It's kind of funny. If you actually go to the speakers and they're talking about Ruby subjects, and you say to them, "What are you actually doing?" And I would say a good half of them have this little guilty secret that they're not actually doing Ruby anymore. But they're doing Elixir. So there's evidence, I think, all over the place. And I know that I have kind of like, some kind of, confirmation bias thing going on. But at the same time, it seems to be the case that, this is a transition that we're in the middle of.
Yeah, that makes sense. It's funny. Yeah, I talk to a lot of people that are kind of in the same boat. I mean, some people are in companies where they started with Ruby and they're still on Ruby. But yeah, it seems like about half the people that I'm talking to, they're either have moved a whole bunch of stuff to the front end and they're doing as much or more JavaScript as they are Ruby, or they've moved on to Elixir or, something else that, works out for them, on the back end for one reason or another.
Yeah. I mean, you remember that Ruby really didn't become popular until Rails came along?
Yeah.
And Rails was one of those kind of perfect storm things. It hit just at the point where the world suddenly needed to be able to create web applications quickly and apparently, effortlessly. I think it's fair to say that Rails did change the world in that way. Mm-hmm. I think that people's expectations of what you could do as a small team underwent dramatic revisions. I mean, you no longer needed 400 people to create a decent company's, web presence. You could do it with 5 or 10 people.
Yep.
And that was really, really big. And because of the benefits, everybody was happy to paper over any of the issues. And so the performance and scaling issues, people would say, we'll make fun of it. Rails doesn't scale. And to some extent, it was true. I mean, if you were in the kind of heady days of an IPO, you could afford to throw hardware at things.
Mm-hmm.
But there comes to be a point at which that's no longer a good idea. And it's not a good idea for an individual company, because managing software that runs across, a cluster of 100 servers is way harder than managing software that runs across 2. If you're a polar bear, then you would much rather they were running just 2, because running 100 is 50 times the power consumption, 50
mm-hmm.
times the carbon footprint, 50 times the warming, and a whole bunch of square feet of ice flow that you can no longer stand on. So there's a number of good reasons to say that scaling is important, and being able to laugh it off by saying throw hardware at it. It worked, but it no longer works. The environment has changed, and so a language where scaling, if you like, is a primary concern, as opposed to we can handle that, I think is significant. And I think a lot of people have seen that. If you're a company and your current, server bill is, I don't know, 100,000, $1 million a month, whatever it might be, if you can drop that down by a factor of 100, then that's kind of significant, And you can do that with Elixir.
Yep.
I mean, it's been measured. I mean, 100 is actually kind of conservative, depending on your database needs. But, and that's significant. And here's the other cool thing about that. In the same way that Rails said that time-wise, we can get you to market faster. And therefore, if you're a startup and you want to get out there as soon as you can, this is the way to go. Well, now we can also say we can get you there fast, but we can also get you there cheap. And run rate is obviously a very important thing. And I would imagine for a lot of these small startups, their back-end costs, their server costs are a significant portion of their run rate. So being able to say we can basically reduce those by a factor of 10 or whatever it might be, is a big deal. It makes a whole lot of things viable that weren't viable in the past.
So I want to kind of skip back a little bit to the discussion about computer science programs. So at this point, I mean, you're kind of in the thick of how computer science works. How should people get into programming these days? Is a computer science degree still kind of the way to go? Or is the market changing? Or, do these programs, set people up as well as the boot camps do, or some of these other self-learning options?
Well, I think there's no one answer to that, because it depends to some extent what you want to do or what you think you want to do. I think it also depends on your own preferences for learning style. I think that the one piece of advice I would give, having actually, spent some time with my students and you're just sitting chatting with them after the class, is you do not want to get into computer science because your parents told you that this is a good way of having a good, solid, secure future. Mm-hmm. A lot of the students that I dealt with, particularly the foreign students, it's kind of sad because, their family all saved up to send them over here so that they could, get a good degree and then come back and earn the kind of money that a software engineer earns. So it's an investment on their part. And these kids are under phenomenal pressure. They're not enjoying it at all. For them, it's a family duty. And that's going to come back to bite them. I mean, it's honorable, and I really respect what they're doing. But it's not a reason. We're in a kind of industry where if you don't really enjoy it, it's hard enough that you're not going to do well.
Yep.
So, I think I understand the pressures and everything else, but in that particular case, you need to say, this is not going to work. It's kind of like saying, ballerinas make a lot of money. Get out there and be a ballerina, and oh, by the way, lose some weight. It's just not going to work. So that's a reason not to get into it. I think the thing to do is to notice your passion early. Notice that you enjoy, making things work, or you enjoy hacking at a web page, or you enjoy whatever it might be. And then find paths to let you express that. And those paths might be teaching yourself. They may be finding some local person and, glomming onto them as some kind of apprentice. It may be do a boot camp. It might be take a 4-year course. It really depends on, what works for you. But I don't think that you have to take a 4-year course in order to see yourself as a software developer. In fact, many of the best software developers I know have never been near a computer science course. And in fact, quite a few of the good ones have never actually graduated college. They didn't need to. They didn't feel the need to. And so, I think, going along just because that's what everybody else does, that's not the way. You need to think to yourself, what is it that I need to learn? And how do I need to learn it? And then find something that works for you. And if you're doing that, and if you're looking and you say, I need to go to a course, whatever else, then spend time to make sure that the teachers on that course are actually doing the kinds of things that you want to do when you graduate. In the same way that if you wanted to become a lighting technician for the theater, right, you would want to make sure that your teachers were also lighting technicians, and they could tell you, or at least had been lighting, and they actually are not just telling you the theory. If you wanted to become a skydiver, you really don't want to spend 4 years in a university learning about Reynolds numbers and the strength of nylon and all this kind of crap, and never actually jumping out of an airplane. So make sure that the course and the teachers are aligned with your own personal goals.
Right.
And if you can't find one, then I would say initially at least don't compromise. I think my experience with IT shops is that the ones that you want to be part of are good enough to recognize that it's the person and not their knowledge that they're hiring. And so if you were to go along to them and say, okay, here's the deal, right? I really want to get into name whatever it might be, and there is not a course out there that will do it. I went to the following 6 places, and here's why they're not going to work. So instead, I've been teaching myself, and I've been learning this, and this, and you guys seem to be the best that I can find in my local area. So here's the deal. I would like to apprentice with you, right? I will take 1/2 of what you currently pay your junior developers for a year, and I will work as hard as I can, and at the same time, you will help me become more effective by letting me pair program with your good guys. And at the end of that year, we'll take a view, and if you like me, you can then start paying me a decent salary. I think that is perfectly good as a way of getting into the industry.
Yep.
And as long as you're prepared to keep doing that throughout your entire career, then, you'll have a career for life.
Absolutely. So is there anything that you feel like you can share with the industry as a whole from your experience teaching this course? I think we've gotten a lot of this, but I just wonder, are there things that we just assume about computer science degrees that, may or may not be true, or things that have changed maybe since some of us have graduated?
Well, I think for a small company, everybody already knows this. For a large company, I think the important thing is not to let the HR department do the hiring.
Mm-hmm.
Because it's the HR department that will say, well, what are the criteria? And some project manager somewhere is going to have to invent criteria just to keep them happy. And that's where you get the, must have, 27 years of Ruby experience, and that's just totally bogus. So if you're working in a large company, work out what it is you want in a developer, and hint, enthusiasm trumps just about everything. And then hire for that. And don't, if you can bypass HR and just go, straight to the people that you want, I think you'll be well better off. Or come up with criteria like, must be able to fog a mirror, and, open the floodgates that way, and just like
Yep.
pick. Or, go to local. I mean, I was actually, my first job, I was hired away. I started a PhD program, and I was hired away from it by actually a friend of my tutor's who was forming a startup. So if you are looking for developers, you don't necessarily have to go through the agencies and everything else. You can go to local maker groups, or local community colleges, or wherever else you're likely to find a concentration of the kind of people that you would like, and just start talking. And if the people you're talking to aren't immediately looking, I betcha that they will know somebody who is, and you network that way, and you'll bring in good people. And ignore the qualifications, look at the qualities.
I love it.
That's a buzz phrase. I like that one. But honestly, I mean, I think personally, okay, I'm the worst person to talk to about hiring, because I really don't like doing hiring stuff. But at the same time, because that means I tend to kind of skimp on doing things like background information and things, I tend to get the more extreme hires. So, I will typically hire people who end up being absolutely atrocious, or who are hidden gems,
Mm-hmm.
and you would never ever predict which ones were which. It's almost impossible. So, some of the worst people I've hired have been on paper the best qualified. One of the best people I ever hired was an alcoholic history major. And he was an okay programmer, but my God, he could put energy into a project team like you have never seen, and it was just, you would never be able to guess that from looking at his resume. So, I think take a chance and invest in the people that you bring in and just see what happens.
Sounds
Which
good.
Actually, that ties back to another thing that I was saying to these guys at SMU. And because at one point, I can't remember what we were talking about, and they got really good at diverting me off because, as I am a bit of a gadfly when it comes to concentration. So they discovered that they could lead me down these blind alleys. And at one point we were talking about careers. And I kind of shocked them, I think, because I said to them, you don't want a career, right? The last thing you want coming out of college is a career. So what you want is experience. And so you should spend the next 5 to 10 years job hopping. Right? Not so often that it makes you look like you're unreliable, but at the same time, do not find somewhere and then stick at it for the next 10 years, because that's not the way it works. You have no idea what you want to do right now. And the only way you will learn what you want to do is by trying things, by sticking your toe in the water. So make it a habit of looking for things that look interesting, do them, and if it's not working out, move on. And if people start questioning that in your resume, you say, that's why I'm doing this, right? I'm doing this because the only way to get to be a good developer is to have lots of experience. And the amount of experience you get drops, I don't know, probably exponentially the longer that you've been in a single position. So, I may not stay with you forever, but I can pretty much guarantee that for my age, I have more experience than anybody else you'll talk to. And if you have an interesting environment, then I will be staying.
Yep, that's terrific advice. All right, well, let's go ahead and do some picks.
This episode is sponsored by Compose.io. Compose is a fully managed database hosting with extra security, scaling, and performance. Hosted on dedicated SSD servers, you can pick from 9 highly available databases: MongoDB, Elasticsearch, Redis. Compose Enterprise comes with easy scaling, which means you can add additional nodes at any time. It's auto-scaled resources like storage, memory, and IOPS, RESTful APIs, central console to manage all your deployments, and premium support with guaranteed response time and priority ticketing. With Compose Enterprise, you can free up your time to focus on building your app instead of managing your database. Check them out at enterprise.compose.com.
Oh, Lord. Okay, I'm going to have one pick because I'm a radical and I'm going to break your rules, all right?
Okay.
So, but you can do picks first because I know how this works, and you guys are supposed to do picks too, right?
That's true, we are.
So let's think, you normally have a panel of 5?
Yes.
So you have to come up with 15 then, is that true?
No, not today.
Oh, all right.
I get to make
so
the
who
rules.
Goes first?
I can go first.
Right.
That's fine.
You go first.
So a few things that I have been using lately that have really been helping me out. I recently being within the last few months, switched over to a Windows machine just because I could get a more powerful machine that would run Windows, and I wasn't locked into the Apple ecosystem as much anymore. And I still miss Linux. And so a few things that I've been using for that. One is the Ubuntu Bash on Windows is available. If your flavor of Linux is more along the SUSE lines, at Microsoft Build, they announced that they have a SUSE Bash for Linux. So if that's your flavor, then you can go that way. I personally prefer Ubuntu, so I've been pretty happy with that. And I can install Ruby and Rails and all of the other tools that I use, and it works pretty darn well. For some of the things that I just couldn't quite get it to work the way I wanted, or I felt like I needed something a little bit more dedicated, I've been using VMware Workstation, and I've really been enjoying that too. So between the two, I tend to get everything that I want. I found a tutorial online that showed me how to get a Mac OS VM running. So yeah, I kind of get all of the worlds that I want, and that just works out really nicely. So I'll just pick those. Dave, do you have some picks then? You're going to break all the rules?
Yes, I will try. Just a question, is that VMware, is that the free one, the workstation?
No, I had to pay for it. I think they do have a free version, but I don't remember.
All right, so my pick has absolutely nothing to do with software. And that's deliberately the case. It is also remarkably vague because the result of following this rule will be different for every single person. But the pick is to make sure that you have something in your life that is relatively significant, that is relatively mechanical, that you can fix if it goes wrong. And so I was thinking about that because about 5 years ago, we moved out more country-ish, and I got myself a tractor. And tractors, by their nature, are not sleek machines, at least not the ones I can afford. So it's very much kind of like someone from the 50s would recognize it. All of the workings are exposed, and everything in it is kind of understandable. And, we don't have like an engine control module and this kind of stuff. It's all, gears and relays and everything else. And I got thinking about this because yesterday I was out on the tractor digging up some asphalt, and I blew a hydraulic coupling. And I had incredibly good diagnostic skills here because, wow, recognizing you blew a hydraulic coupling. Well, it was kind of a hint when I discovered I was actually covered top to toe in hydraulic fluid. So I turned it off and went and had a shower, and, I got the instruction book out, and they basically said, if you break a hydraulic coupling, fix it, and then put your hydraulic fluid in. So I thought, okay, I could do that. And I did. And I was thinking, if that had happened to my car, right, I would have to get someone to tow it somewhere, and they would have to get the computer out to work out. It was just like, the feeling that you actually are in control of at least one thing in your life that you can fix, I think, is really, really important. And particularly as the world is getting more and more complicated, and your cars are looking more and more like, you open the engine compartment of a car, you see a solid block of plastic and aluminum. Right. In the old days, you'd see wires and spark plugs and all this kind of stuff. You need something in your life that you can fix. I think everybody does. Something is where you can, take a screwdriver to it or whatever it might be and actually make it work if it goes wrong. Because otherwise, it's really easy to build this feeling of, I'm not in control. Anything that goes wrong, I have to call in some expert. And that, I think, is a really bad mindset to get into. So that is my pick. Something that's significant, that can go wrong, but that you can fix.
Nice. Yeah, I spent time working on my car. In fact, I'm kind of tired of working on my car. But yeah, I agree.
And if anybody wants to come and help work on my tractor, I got a whole bunch of outdoor work that needs doing here. So, it's like that Tom Sawyer thing, $5 and you can actually work on my tractor and dig up some ground or something.
That actually sounds kind of relaxing.
I currently have this community I live in back in the 60s or 70s or something. They paid to put a tennis court in, and they did a good job, but it's what is it now, 40 years old, 50 years old. Mm-hmm. And so it's falling apart. No one wanted to spend the $70,000 to fix it. So I've been politicking for a year to have them let me take it down. It turns out the fencing is the easy part. You go to Craigslist and say, I've got a tennis court's worth of chain link. And I got my first response 14 minutes after I posted the ad. But the asphalt is another story. Nobody wants asphalt. So, so I've been going out for 2 hours every night after the sun's low in the sky and been digging up asphalt. And it really is, it's a great time just to sit and think about what you're doing and, generally contemplate the world. So that's my other recommendation, I guess, is get a tractor and a tennis court and then destroy it.
There you go. All right. Well, we'll go ahead and wrap this up. Thanks for coming, Dave.
Hey, totally my pleasure. Always my pleasure.
All right. Well, we'll catch everyone next week. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.